Orbiting a planet so distant it cannot be seen with the naked eye, 2 worlds of life were accidentally sprayed directly onto a NASA probe. What evokes the image of an ocean similar to those on Earth? According to Space Magazine, this fascinating data was overlooked for nearly 40 years. As scientists around the world work to analyze the data sent back by the Voyager 2 spacecraft, one of NASA's farthest traveling spacecraft has begun entering interstellar space. This is data about Uranus, the 7th planet in the solar system. Among the moons orbiting it, 2 particularly fascinating worlds are Ariel and Miranda. They are all named after characters in a Shakespeare play, unlike the moons of other planets, which are named after figures from Greek and Roman mythology. The mechanism by which they accomplish this remains unclear, but astronomers believe there is a very compelling possibility. Europa or Saturn, moons of life. The way they release material particles from the subsurface ocean to the surface is also very similar to Europa and Enceladus. The lead author of the study, Ian Cohen, from the Johns Hopkins Applied Physics Laboratory in Maryland, USA, said, "It comes as no surprise that energetic particle measurements are the key to unlocking the oceans of the subsurface world." Thus, Dr. Cohen's research team has discovered 2 more potential ocean planets, which NASA wholeheartedly welcomes in the long journey to discover worlds capable of sustaining life. This demonstrates that a potential future mission, sending a dedicated spacecraft to explore Uranus, would be immensely valuable. And its highly enigmatic moons, with a confirmed count of 27. Could life exist within Jupiter's Eye of the Storm? The Eye of the Storm is perhaps the most mysterious spot on Jupiter, and it lies right within one of the most famous storms in the solar system. Jupiter possesses an extremely harsh atmosphere, where countless violent storms occur. However, the most famous storm is undoubtedly the Great Red Spot. Scientists predict that this storm is so powerful it could swallow the entire Earth. It was first observed by humans on Earth in 1830. The Great Red Spot on Jupiter is a massive storm, located within the planet's troposphere at a depth ranging from 0 to 50 kilometers. It has existed for at least 355 years. Its external wind speed is extremely high, capable of reaching from 430 to 680 kilometers per hour. Meanwhile, the wind speed at its outer edge is slightly lower, below the threshold of 430 kilometers per hour. The inner area, also known as the Eye of the Storm, is completely opposite from the surrounding region. This place is relatively calm and stable, with no clouds or strong air currents. Could any form of life exist within the very eye of the storm? Actually, the environment there can be very tranquil, having no direct connection to the turbulence of the storm. However, it is also possible that such an environment is not suitable for life to exist. Currently, we know that Jupiter's atmosphere can be divided into 4 layers. These layers are the troposphere, stratosphere, thermosphere, and exosphere. Liquid interior, which is entirely different from Earth. Therefore, its atmosphere is primarily composed of hydrogen and helium, with only a small portion consisting of other compounds such as methane, ammonia, hydrogen sulfide, and water. Jupiter's troposphere is characterized by a gradual decrease in temperature with increasing altitude. This particular feature allows this atmospheric layer to host various types of clouds, including ammonia clouds, water clouds, and hydrogen sulfide clouds. Jupiter's storms may originate from a thin atmospheric layer beneath the water clouds, where scientists have observed lightning. According to various data sources, the thickness and temperature range of Jupiter's troposphere vary significantly. It is currently recognized that the planet's troposphere extends upward to an altitude of approximately 50 kilometers from the observable cloud layer, corresponding to the 1 bar pressure level. Within this layer, the temperature increases progressively from about -163 degrees Celsius to approximately 67 degrees Celsius. Jupiter's troposphere is primarily composed of hydrogen and helium, along with small amounts of substances such as water, ammonia, ammonium hydrosulfide, and methane. These substances form clouds with distinct colors and densities, distributed at varying altitudes. The white bands of ice crystals in the highest cloud layers are called zones, while the reddish-brown bands of ammonia and sulfur in the lowest cloud layers are called belts. Of course, the thickness and temperature range of Jupiter's stratosphere also vary when measured from different datasets. Generally, the stratosphere begins at the end of the troposphere and extends upward for approximately 50 kilometers. In this atmospheric layer, the temperature tends to gradually decrease, from about -67 degrees Celsius down to approximately -163 degrees Celsius. The highest clouds, composed of ice crystals, form a ring around the polar regions. In addition, the complex and dramatic variations in wind speed within Jupiter's stratosphere also generate diverse vortex structures and characteristic storm phenomena. Scientists have traced the trail of one of the most primordial molecules. Near the poles, strong winds with speeds of up to approximately 400 meters per second are present. These winds travel at speeds of 1,450 kilometers per hour, more than 3 times faster than the wind speed of the most powerful tornadoes ever recorded on Earth. Accordingly, many believe that life is unlikely to exist in Jupiter's eye of the storm. Jupiter's atmosphere contains large amounts of toxic gases such as ammonia, metal, and hydrogen sulfide, which would be fatal to most life forms. In summary, while the possibility of life existing in Jupiter's atmosphere cannot be entirely ruled out, but at least up to the present moment, no signs of life have been detected there. However, scientists now believe that some of Jupiter's moons, such as Europa, could potentially harbor life. Beneath its frozen surface, there likely exist vast oceans of liquid water. Additionally, there are tidal forces and the phenomenon of cryovolcanism, which are caused by the activities of ice on the moon's surface. It is possible to create an ideal living environment for certain species on Earth. Or there may have been, and may still exist, life forms of microorganisms that we have never known about. A robotic helicopter is on a mission to search for extraterrestrial life on Titan, Saturn's moon. The robotic helicopter named Dragonfly will become a companion to Saturn's moon Titan, the place that NASA once likened to a second Earth. Dragonfly, also known as Chuan, is a space mission currently in preparation and is expected to land on Earth in 2027. It is anticipated that by 2030, we will be able to discover an Earth-like planet in outer space. With a design resembling a helicopter, Dragonfly is a spacecraft model specifically designed for landing missions, and is also a type of robot capable of autonomously operating certain functions. NASA has explicitly stated that this will be a mission to hunt for extraterrestrial life, or at least find precursors, the primitive elements that set the stage for life, gradually taking shape on this mysterious planet. This will help scientists clarify events that occurred on Earth in ancient times. Life may have formed through a fascinating series of chemical reactions, commonly known as prebiotic evolution. Complex chemical composition rich in carbon, with subsurface oceans and intriguing features right on the surface. Featuring landscapes with Earth-like characteristics, this has long made Titan a promised land for NASA's Europa or Saturn. NASA's exploration rover will be equipped with a mass spectrometer named Dragonfly, designed to build bridges with Earth scientists, help them study the surface of Titan remotely. According to Dr. Melissa Chainer from NASA's Goddard Space Flight Center, we want to investigate whether this type of chemical could have played a key role in primitive prebiotic systems on Earth. Could there be life on Titan? The Dragonfly mass spectrometer will scan Titan's surface, searching for the necessary components for exploration. To bring this mass spectrometer to more locations, this vessel will